Welcome back. Now that we've learned a bit about neurofeedback as a whole and have helped our clients understand what it entails, let's take a closer look at the science behind how we define, measure, and interact with brainwaves. When you think about a brainwave, think of dropping a rock in a pond. When the rock hits, you'll see rings ripple through the water. This is a very good model for a brainwave. The number of times that these rings recreate themselves in 1 second is what we call frequency. We measure frequency in either cycles per second or in hertz. Frequency helps us divide brainwave activity into the following 4 categories. Delta waves are the slowest brainwaves. Their frequencies measure at just 1 to 4 hertz. They often occur during sleep. If your brain were a car, delta waves indicate that it is parked and turned off. Theta waves, like delta, are also low-frequency slow waves with frequencies of just 4 to 8 hertz. They are often seen during the brain's twilight states. However, they have also shown to be crucial to memory storage. Continuing with the car analogy, the key is in the ignition, but the engine is just warming up. Alpha waves, with frequencies between 8 and 12 hertz, are faster moving brain waves that are associated with relaxation or unfocused activity, such as multitasking. With alpha waves, our car's engine is turned on and fully heated, but the car remains in neutral. And finally, there are beta waves, the fastest frequency at 12 to 25 hertz, which are associated with focused concentration. For our car analogy, the engine is on and the car is moving and responsive. The 4 types of brain waves, as defined by their frequencies, will be referenced often in the later sections of this course. Be sure to familiarize yourself with them now. So we know that the signals our EEG sends to the brain can disrupt and reset brain activity. How does that help the brain heal itself? The answer is actually fairly simple, and it lies in your autonomic nervous system, specifically in its 2 main modes, relaxation and fight or flight. Relaxation is an expression of what we call our parasympathetic nervous system. When we are relaxed, our brain can rest, recover, and if necessary, reoptimize itself. While relaxed, the brain can consider a multitude of options before committing to one. Fight or flight, while an essential element of human survival, does the exact opposite. It is an expression of the sympathetic nervous system. As the brain prepares to push itself to an extreme in the face of a threat, decisions are reduced to basically yes or no only. Sometimes the brain can get stuck unnaturally in this fight or flight response. PTSD, or post-traumatic stress disorder, is a particularly good example of this, where the threat is gone, but the individual remains in a form of fight or flight response. Much like our frozen computer from the last module, when we reset or disrupt this activity, we give the brain the ability to reboot and rebound appropriately. This stimulates the parasympathetic nervous system, which can help restore fight or flight brain activity to a relaxed state. As the brain reboots, it naturally optimizes itself, thus breaking any stuck or flawed patterns that may have been triggering the fight or flight response. After a few sessions, the brain's neuroplasticity is strengthened, and its ability to maintain the proper responses without needing to be disrupted by the EEG can begin to take over. Direct neurofeedback is the process of using very low energy signals to affect the nervous system as a whole. These signals are designed to stimulate parasympathetic reactions that allow the brain to relax, recover, and reset. By breaking the brain free of a stuck pattern, the brain can ultimately optimize the creation of future patterns, thus optimizing itself as a whole.